Hello class, this is Taylor Baker. My project is optimizing collaborative task completion for hexapod robots using reinforcement learning. My goal is to train this robot, which is called the APOD robot, in simulation to do various tasks. So why I'm doing this project is for my master's thesis, which is in collaborative task completion with robots. And then I also would like to understand more about reinforcement learning. How am I going to use this? I'm going to use Unity and with a package called ML Agents to do the training. And then I will set up a few different reinforcement learning environments to help train. So my first environment is for the agent to bring the ball to the goal. So it, this is blue cube is my agent. The goal is to go find this ball placed in the environment, and then once it has the ball, it needs to go to the goal, which is this white cube. So this is my reinforcement learning cycle for this environment. You can see the reward structure is as follows. If the agent hits the ball, it gets a +1. And if the agent has the ball and hits the goal, it gets a +2. And then here are some other minor ones. After training, this is the graph with my cumulative reward on the y-axis and the number of steps or actions the agent took. You can see it goes up to 2 million steps. You can see the learning curve. Here's what it looks like with the trained model. You see once it hits the soccer ball's position is just the same as the agent, and then it ends once the agent touches the goal. Okay, here's my second environment. The goal of this is for the blue agent to push this pink target to the goal area, which is just this white area right here. So same kind of structure, a little bit different rewards. I did put a couple rewards to measure the distance for the agent and the target, from the target to the goal or agent to the goal, and it gets a positive or negative reward depending on those numbers. Here's what the training results graph looks like. Once again, with the cumulative reward or the steps or the actions the agent took. Right here you can see the agent stopped learning about 1.25 million steps after 1.25 million steps. So you can see that it maxed out and learned pretty efficiently right there. Here's the example. I have all these multiple environments set up. Here I'll zoom in on this guy right here on the bottom left, just to get a better look. You can see the agent finds the target and then pushes that target to the white area. Okay. Next environment I set up is the same kind of idea, just with multiple agents, multiple targets. I used a different algorithm here because this algorithm is better for multiple agent training, because you can assign rewards to the whole group of agents rather than just individual agents. So here you can see I have the 1, 2, and 3 targets. That not only corresponds with the size of the target, but also the weight of the target. So with the 1 target, one agent can push it. The 2 target, at least 2 agents have to push it, and then the 3 target, all 3 agents have to push it for it to be able to move. Here's my rewards. I did a little bit different. I only give the agent a reward if it hits or pushes the targets to the goal. So it takes a little bit longer, but you can see right there how I have it set up. Here's my graph. You can see it's definitely still learning after 25 million steps, and with the cumulative reward, it still needs a little bit more time to train, but you can see there's definitely a learning curve in there. So it is training and learning. Here is the video of the demonstration of the trained model on my different environments. right here you can see the agents. They understand that they need to push together, but they just haven't quite gotten there. And just with a little bit more time, I believe they'd learn how to. I ran the training for about 8 hours, and this is where it got to. Okay, so since I mentioned that this is for my thesis, I still have a couple more things that I'd like to do for future work. Implement the hexapod legs for each agent once I get those 6 legs per agent implemented, then have them push targets to the goal. And then after I get all that, actually put the train model on the actual APOD robot. So lessons learned, the biggest thing is just the difference between training one agent versus training multiple agents, I think was the biggest lesson learned. And that's my presentation. Thank you.